Okay, greetings. Let me get this and put this back in the corner, slide that back there, and there we go. Full view of me talking to you. This will be a fun lesson. Where basically you're going to repeat the same procedure 3 times. There are three sporting incidents that involve an impulse or a sudden, very hard force for a very short duration that causes an extreme change in velocity, which causes which creates a large average force. And what are we talking about? I sound like Alec Baldwin and Gary Glenn Ross there. So what are you talking about? You're talking about what he does is always be closing speech. But anyway, for those of you old enough to know about that. If not, if you don't know about the reference I was just making, and you're in a really good mood and you need to be brought down, if you want to be you want to think that the world is a horrible place, you can watch that movie. It's not very uplifting at all. Or you can watch Trump at the UN. Anyway, and we're all gonna die. Anyway, goodness gracious. I'm sorry to get that was actually more comic than political. Anyway, it's what happens when you get somebody who learned how to rise to power by being associated with professional wrestling. That's what you get. We've got we've got Vince McMahon as our president. Anyway, so I should probably cut this. Oh my. Anyway, let's move on. So we're going to look at some very violent collisions, and I apologize to any of you who that no, I don't. That's the problem with when professors get political is it's all top down. You don't get a chance to counter back and say, hey, but wait a minute. Yes, Hillary had flaws too, like her new book out called Not My Fault. Anyway, it was all your fault. Jiminy Christmas. So anyway, sorry, I'm in a mood, and I'm going to get in a real mood when we start talking about concussions at the end of this lesson. So have fun with this now, and it is a little bit intense. It's gonna be intense, but we're going to walk through it. And once I walk through one or two, when we go to you'll be fine. I think you'll be able to do it without much trouble. Okay. So without further ado, we're going to talk about when we smash things together, boom, and they clack like that. And what happens when items collide? Okay, all right. So let me just start off with the notes. Now you're getting some fancy notes here. This is we're not messing around here. This ain't no party. This ain't no disco. This ain't no fooling around. So anyway, here you go. Linear momentum. Impulse, conservation of linear momentum, elastic and inelastic collisions, center of mass. Oh, and since you've got this, you can go look at this movie on the physics of hockey, which is put out by NBC Sports. I would do it, but whenever I put up, when you're using QuickTime video and you're doing a class within a class type thing, it doesn't work very well. It does, in fact, it doesn't work at all. All right. So if you want to do that, the way you would access that is you would go to a full screen. Oh, that's the other thing. Some of you had, one, and so that means there might have been others, had trouble accessing the videos if you ever have trouble accessing the videos or my lecture part and you've done all the troubleshooting of one, you've cleared all your cache memory. 2, you're not using Safari. Safari does not want to work with Blackboard very well. Safari does not want to work with us amateurs and YouTube very well because they're trying to protect, those iMac users. And you've done everything you possibly can to watch the videos. Here's the last ditch effort. Go ahead and just copy the thing. Copy the link and paste it in the browser outside of Blackboard, and then it should work without any trouble. Okay, so we're going to talk about linear momentum and the impulse. This is what we're just going to talk about these first two. We'll get to the conservation of momentum here in probably in next week's lesson. Okay. All right. So definition of linear momentum: momentum is equal to the mass of the object times the velocity. Now we know the force is equal to force times acceleration, mass times acceleration. Momentum is just mass times velocity. Now these are some highfalutin, so SI units is kilograms meters per second. These are all for physics 210, and don't be alarmed by this one. I thought I erased this. We're not even going to talk about this, but we will talk about it a little bit later on. Okay. All right, and don't worry about that. Now here's where we're really talking. All right, so linear momentum. If an object's momentum changes, a force must have acted on it. In other words, because I have a change in velocity, that means I have an acceleration. So this force equals ma. So there's had to be a change in velocity or a change in time. Okay, so Newton's second law of motion in terms of momentum. It's a change in momentum over a change in time. The net force is equal to the rate of change of the momentum. So in other words, but the thing is, this net force is very, very short in duration. Boom. And here it is. And we'll talk about this in a minute. I think I've talked too long. I'm going to go ahead and close. This will be track 1. And we'll start here.